Okay, today, it will just be you and I and my two little whiteboards and my first IMO question. You know, 99% of the time, or actually 99.99999% of the time, I don't even understand what the IMO questions are asking. But this one, not only I was able to understand, but I was able to solve. So have a look right here. This is from the 1975 IMO, and this is question number 4, right? So we are going to find the sum of the digits of the sum of the digits of the sum of the digits of the number 4444 to the 4444 power, right? So I'm gonna try my best to give you guys all the details. However, I've never participated in the IMO contest because I'm just never that smart, right? So I don't know how you're supposed to write so you can get the full 7 points, but I'm going to give my best try for you guys, right? So here we go. Of course, I don't want to write down the sum of digits like 20 times in this video. So I'm just going to have a notation right here, right? So I'm going to call d of n to be the sum of the digits of the n. And of course, right here, you should put in a whole number, right? So just like that. So let me give you guys an example. So for example, if you are trying to calculate the digit sum of, let's say, 4, 9, 9, 7, 2, 8, something like this, right? Yeah. All right, so this is all you have to do. So just go ahead and add all the numbers. So 4 plus 9 is 13, plus that is 22, plus 1 more is 29, plus that is 31, plus 1 more is 39, right? So this is it. And then of course, you can do it again. The digit sum of 4, 9, 9, 7, 2, 8. This right here, we know is 39 already. So just do the digit sum again. 3 plus 9 is 12. And if you do it again, of course, you just get 3. And you see, it gets the digit sum, it just kind of gets smaller pretty quickly, right? All right, so going back to the question, you see we have 3 of the digit sum that we have to do, meaning that this is what we want. For this question, we want to have the digit sum of the digit sum of the digit sum of the number 4444 to the 4444 power, like this, right? So 1, 2, 3. Sorry about my parentheses. All right, so this is what we want. Now I'm going to give you guys some of the details right here, right? And these are the things that we'll be using later on along the way. So first of all, let's investigate the digit sum function a little bit. So for example, the first thing is, if you are trying to find the digit sum of two-digit number like this, right? Well, this right here, whatever these two numbers are, the biggest that this can be is the digit sum of 99, right? So this right here, the biggest is going to be the digit sum of 99. This is going to be the biggest. And of course, this right here, 9 plus 9 is 18. So the digit sum of a two-digit number, the biggest for that is 18. And then of course, you can just extend this idea. If you have a three-digit number, is the maximum is the digit sum of 999, and that will be 27 and all that. So that should be pretty clear. However, the one thing that you have to be careful with that, so I'll just say this is a little warning. So this is the little warning. This is true if you replace the numbers with 9, that's okay. But if you have, let's say, two numbers, let's say m is bigger than n, right? Two numbers, let's say this is bigger. This right here does not imply the digit sum of m is greater than the digit sum of n. It does not imply, right? For example, we all know 1111 is bigger than, let's say, the 7. But if you look at what's the digit sum of 1111, the digit sum of 1111, is this bigger than the digit sum of 7? Well, no, because this right here is 4, and this right here is 7. The digit sum of a single digit is just the digit itself. So this right here, as you can see, this is not true. So you have to pay attention to the inequality carefully. And of course, it could be true, but it's not always true. So we have to just do it really carefully. Now, with this in mind, I'm going to just use the first idea. I think it's a good idea to figure out how many digits there are for the number 4444 to the 4444 power, right? Because we can set out an upper bound for that, and that's pretty good. So now let me just erase the board right here, and then let's get into this. So let me know how you guys are doing, right? Hopefully everybody's doing well. Okay, here is the deal. I want to figure how many digits this number has. You might have a few ways to do it, but this is how I will do it. Let's go ahead and compute the following. I'll just say this is my check. I'm going to check. I will take the logarithm with base 10 of the number 4444 to the 4444 power. And why do I want to do that? Well, right here, I'll just give you guys the reason. For example, if you have a number that say 125, like this. If you have this number, of course we know this right here is bigger than 100 and this right here is less than 1000, right? So this is good, but if you apply the logarithm of base 10 throughout this right here, and because log is an increasing function, so the inequality will maintain, and the log base 10 right here, this is 2, and this right here is log base 10 of 125, and log base 10 of 1000, this right here is 3. And again, log is an increasing function, so you know this is true. You know log base 10 of this is in between of 2 and 3. If this number is in between of 2 and 3, you can just go back here and say this right here has 3 digits and works for any 3 digits number. You can put down log base 10 of 852 and it will still be in between of 2 and 3. And again, if you have a number that's in between of 2 and 3, you can go back and just say how many digits this has, right? So that's why I'm computing that. And the best thing for us to use the logarithm is, of course, we can bring the power to the front, but please do not minus 1 because we're not doing calculus, all right? So let's go ahead and just do the following. This is 4444 times, this is log base 10 of 4444. All right, now come back here a little bit. As you can see earlier when we had a 3-digit number, this number is in between of 2 and 3. This right here has 4 digits, right? So this number is in between of what? 3 and 4, the maximum being 4, right? And of course, this cannot reach the maximum, but we can do the following. We can just say this right here is less than, of course, I will maintain this, namely 4444, but I will just multiply this with 4. Because again, this right here is less than 4. We know that from this idea right here. So that's good. And then, of course, let's just compute this. You can see that this right here, just go ahead and do it. We have 1616. So it's 177776. Let's see. 16, 1, 2, 3, 4, and then one more. Is it? All right. 16, 16, 16. Yeah, so 1 with 3, 7, and then 6, like this, right? So what this means is that, well, this number, 4444 to the 4444, has at most this many digits. Actually, technical say has no more than this many digits. So let me just tell you guys right here. So, right, the number 4444 to the 4444, this number has no more than, well, I should just use the term less than, but it doesn't really matter. Has no more than 17776 digits. Right? So that's the idea. And now you see, well, the maximum digit that it can have is like, it has no more than this, right? So of course, you can just imagine if we replace everybody by 9, well, we can set up the bound for the digit sum of 4444 to the 4444, right? So I'm going to use this idea now, but I'm going to erase this right here. Based on this, then we can say the digit sum of 4444 to the 4444, this right here, right, has to be less than the digit sum of, well, I have this many digits at most. I'm just going to be, super crazy. I'm going to replace everybody by 9. So I'm going to say everybody right here is just 9. So I'll just put on 9, 9, 9, 9, like this. How many 9s do we have? Well, we have a total of 17776. So 17,776 9s. Right? So like this, right? Well, if I'm adding up this many 9s, of course we can just multiply. So this right here is equal to 9 times this 17776. And let's work this out. This times this is 54. So 5, and then you have that which is 8, and then 6 which is 9, 6 which is 9, and then 6 times that is 1, 5. So 159984. No. Yes. Nice. Yeah. So the first digit sum right here, right? The digit sum of this right here is at most 159,984, right? So perhaps let me just write this down right here. 15984. I believe that's the number I wrote down. So let me just make sure. 960. Yes, right? So this is good. Again, the digit sum of this number is less than this, right? So we are going to, of course, do this 2 more times. And again, this is just going to give us a bound. So it's not the answer, right? So have a look. Next, if you have the digit sum of 4444 to the 4444 power like this, well, this digit sum is less than this number. I'm going to do the following. However, you have to be really careful though. I will say this right here. Again, just pay attention to this part, right? Just pay attention to this part. I'm maintaining the digit sum, the d of whatever, for the first one. But for this, I'm going to say this is less than. You can replace everybody by 9, but unfortunately, that's not going to come up with a nice argument. What we can do is, we can keep the first digit to be the same, right? We can keep the first digit to be the same. And then I'll replace the rest with 9. So we have 1, 2, 3, 4, 5. So we have this many 9s like that, right? Of course, if this first digit is the same, this right here is bigger than, it's all 9. So of course, the digit sum of this will be bigger than the digit sum of that. Good. And then of course, we're just going to compute it. However, one thing to be careful though, you should not be just adding this up because again, as I said earlier, if m is bigger than n, this actually does not imply the digit sum of m is bigger than the digit sum of n. This is true if you replace everything by 9, that's okay. And then, yeah, it's like that. All right, so this right here should be enough explanation on that. Now let's see 1 plus 9. No, let's do this. 1, 2, 3, 4, 5. 5 times 9 is 45 plus 1 is 46. All right, so the digit sum of the 4444 to the 4444 is 46. Well, no more than 46, right? Now one more. So lastly, digit sum of 4444 to the 4444 like this. Well, earlier we found out that this right here is no more than 46. But again, similar reason, we have to do the following. I will just say this has to be less than the digit sum of, I will replace this with 4, it stays the same, but I will replace the 6 with 9, right? And this right here will tell you 13, okay? And if you're not convinced why I have to do that, let me just give you an example. Because for example, let's say we know 46 is bigger than 39, right? But what's the digit sum right here? The digit sum right here is 10. The digit sum right here is 12. So this right here is not true. That's why you really have to replace this with a 9. And if you replace this with a 9, you can say that this is 13. Of course, it will be bigger for sure. So just do it really, 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 really carefully. All right, so that's all good. So I'm going to leave that. And now, if you would like, you can just make your guess. Pick a number. Well, it cannot be. Do I know the minimum of this? It's kind of hard. I don't know if I can get a minimum from this. But here's the deal. I'm going to do the following. I only have, certain numbers to consider. 4, 4, 4, 4. One thing I will also let you guys to know that is there's a really nice connection between digit sum and when you look at the number and divide it by 9. And that's how you check the divisibility of the number 9, right? So, for example, if you have a number n, this right here is actually congruent to the digit sum. Digit sum, if you mod 9 to it. For example, let's say if you have the number 125 again, right? This right here, well, if you look at the digit sum, which is 1 plus that, which is 2, plus that is 8, let me tell you, this right here is true. Well, if you don't believe me, just go ahead and do the math. 125 divided by 9, this is 1, which is 9, and then this is going to be 3, 5, and then we are going to use 3, which is 27. See, told you this is true, right? Again, if you want to check the divisibility of 9, you can just add up the digit. If it's congruent to 0, that means the number is divisible by 9. So this right here, I think it's pretty clear. We're talking about IMO question, so I don't think we have to give a proof for this. So you can just quote this, I believe. Please don't ask me to prove that. All right. So does that mean we have to do the 4444 to the 444 mod 9? Let's go ahead and do it. Okay, have a look. 4444 to the 4444, right? The way I'll do it is I will just build up my power, not partial fraction, but build up the power in the congruent sense. This right here, let's see. I'm again just talking about mod 9, right? All right, let's do the math. 4444, and then 9, which is 336. Of course, you don't have to do this. You don't have to show work on the test. 81, and then 34, and then 3 is 27, which is 7. Yes. Right? So this right here is congruent to 7 mod 9. Now, this is what we can do. You start with the base, and then you build out the power. But don't do 1, 2, 3, 4, 5, so on to 4, 4, 4, 4 power. What you can do is go ahead, raise this to the second power. You can raise this to a second power. Likewise, you can just raise this to a second power, which is going to be 7 squared, like so. Actually, I'll put on this in red. Put on this in red as well. So 7 squared. And then again, 49, and then we can do this in your head. 49 mod 9. 49 divided by 9 is 5, with the remainder 4. So this right here is 4. And again, we're just talking about mod 9, all right? So this is the mod of 9 world for the rest. So I'm not going to write down everything, just mod 9 all the way. All right, so this is what we have. And then what you can do next is just keep build up the power by squaring it. So right here, next it will be 4444 to the 4th power, which is the same as just square this, which is 4 squared, and that's 16. 16 divided by 9 is 1, with the remainder 7, like this. And then again, just continue 4444. Square that though. Square the number, which you actually multiply the number by 2, so it's 8. And then again, you just pretty much square this, which is 7 squared. And you see, this is actually pretty nice because you see the 4 was 7 alternating, right? So this right here is going to be 4. So it's pretty nice if you just keep squaring the numbers. So this one is 4444, 16. We have to get up to close to 4444 for the power. So just bear with me. This is going to be 7. And then 4444 to the 32. Man, this is going to be 4. And then maybe I fit in one more, 4444 to the 64. This right here is going to be congruent to 7. And then we just have to do it again and again. You know what? I'm sorry. My disk is almost full, so I'm going to erase some stuff. on my laptop, right? So I'm not checking the answer key whatsoever, because this right here is just a matter of writing things down. You hear that? It was just cleaning the trash can, right? All right, now this is going to be the rest, which is 4444 square the number which is multiplied by 2, 128. This is going to be 4. And then again, mod 9 all the way, all right? And then you have 4444, 256, which is 7. And then 4444, 512. And you get 4, 512. I know it's 412 this time. 4444, and then 1024, which is going to be 7, and then 4444, 2048. Man, 4, and then one more 4444, which is going to be 40. Okay, I'm not going to mess this up, otherwise I'll cry. 96. Yes, and that will give you 7. All right, so this is the table that we have. Now, check this out. 4444 to the 4444 power. This right here, I can break this down and I will just use congruent symbol right here. I don't have enough space, so I'm going to write it down below. 4444 to the 4444, right? This is congruent to what? You put this down, which is 4444 to the 4096. And then how much do we need? Well, if you just subtract, you get 8. I know. 4, 3, 348. Yes, 348. I need 348 more, right? So I'll just multiply by 4444. 348. I need 256. And then this minus 256 is 292. Am I right? Yes. And then 92, I mean to have 64. So I just need to multiply by 4444 to the 64 power times 92 minus 64, which is 28. Am I right? Yes. 4444, 28. 28, which is the same as 16 plus 12, right? So I need to 12, which is this and that. Okay, so 4444, and then I need a 8, and lastly I need a detail 4. So let me actually just put everything down right here. Hopefully everything fits. So I believe it was 4444 to the 64, and then honestly I don't remember. I think it was 16, and then just 4 and 8. 4, 4, 4, 4, and then I need a 12, so it's 4 and 8. Let me see. 4, 4, 4, 4, and then 4. Now, let me see if actually these numbers add up to be 4, 4, 4, 4. So, I don't know. Let me see right here. This right here is 96 plus 256 is 253, and then 4 right here. That's good. And then plus... So 64 plus 16 is 80, 92. So I have 92. So 4, 4, 4. Yes, okay. All right, so again, just do the math on that. No calculator, right? No calculator on this, and then just kind of write everything down like this. So, again, we are still in the Math 9 world. So have a look. Let's see. Just bear along with me. This right here is congruent to 7, so now we can just multiply 7 times. This right here is congruent to another 7. And then this right here is congruent to another 7. Right? And then this right here, 16 is another 7. 8 is congruent to 4, all right? And then 4 is congruent to 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right. So this right here is what we have, and I think that is correct. So let's see. Here we are saying 4, 4, 4, 4 to the 4, 4, 4, 4 power. This right here should be congruent to, all right, let's do this in our head, right? 7 times 7 is 49. But we know this right here is congruent to 4 mod 9, right? Because 49, so it's 4. So this is another 4, yeah? 4 times 4 is 16, but that will be congruent to 7. 7 times another 7 is 49, which is congruent to 4. So this right here is going to be congruent to 16. But 16 is the same as 7 mod 9, right? Again, just work this out. That should be 7 mod 9. Now, this is an information. The digit sum of this right here has to be 7. This number, how should I say? This number right here is congruent to its digit sum, mod 9. That's why I told you guys earlier. And then this right here will imply that the digit sum of 4, 4, 4, 4 to the 4, 4, 4, 4 is congruent to 7. Again, this is the number itself is congruent to 7 mod 9. That implies the digit sum of this number is also congruent to 7 mod 9. And in fact, you can just keep doing this as many times as you would like. You can digit sum, and then the digit sum of this. Let me actually just write it. Alright, so you can apply the digit sum again. Let me just write it down again. 4, 4, 4, 4 to the 4, 4, 4, 4. This right here will be congruent to 7. Right? And then one more. Digit sum of the digit sum of the digit sum of 4, 4, 4, 4 to the 4, 4, 4, 4 is congruent to 7 mod 9. Alright? Good. This right here, along with what though? Remember, this right here is with mod 9. But we know that the digit sum of the digit sum of the digit sum of 4, 4, 4, 4 to the 4, 4, 4, 4 power. This right here, per our discussion earlier, it has to be less than 13. Well, have a look. The digit sum of the digit sum of the digit sum of 4, 4, 4, 4 to the 4, 4, 4, 4 is 7 mod 9. And the biggest, well, it has to be less than 13. So what does this mean? With this and that, I'll just put down star and star, star, right? So I'll just tell you by star and star, star. And again, this is my final punch. I will tell you the digit sum of the digit sum of the digit sum of 4, 4, 4. I don't have enough space. I shall make this right here. I don't want to squeeze everything, right? So I'm going to erase this part, right? I shall make this slightly more presentable. So have a look. By star and star, star, I'll just write this down again. By star and star, star. The only number that's congruent to 7 mod 9 and it's also less than 13, of course we are talking about positive number because digit sum is positive, is just 7, right? So by both of this, we can conclude that the digit sum of the digit sum of the digit sum of 4, 4, 4, 4 to the 4, 4, 4, 4, this right here has to be 7. And that's the answer, alright? This right here is the answer. This right here is the answer, right? Oh my goodness. Oh my goodness. And let me just check on Wolfgang Alpha. I'll show you, right? I'll show you guys this real quick. I'm going to turn on my Wolfgang Alpha to show you guys this real quick. Let's see. Digit. You can just type in digit sum. Can you guys see okay? I'm not going to edit this video. Right? So I'm just going to show you a digit sum of 4, 4, 4, 4 to the 4, 4, 4, 4. Okay, enter. 72601. Right? You guys saw that, right? So now, of course, checking the answer on Wolfram Alpha. And I just need the first digit sum because for obvious reason, of course. So now, 4444 to the 4444, again, on Wolfram Alpha, this is equal to 72601. 72601. And then let's do the D of 72601. Well, this is going to be, that's 9. Why do I have hard time adding? 15, and that's 16. And then the digit sum of 16, of course. Haha. Oops, no. It's 7! That's the answer! Alright? Oh my god. This is so wonderful. Yeah. I could not believe I was able to at least not only understand the question of an IMO, right? Not only I could understand what the question is asking, but also I can demonstrate how to solve this right here. And yeah. Whew. Okay, anyway, as always, that's it. I'm too happy right now.